To derive the CSTR design equation, we begin with the mole balance, which is the foundation of reactor design. On the right, you see the notation that we use for the stirred reactor. Let's write the mole balance with respect to A, which is usually the reactant. The reaction can be of a type, for example, A goes to B. So our reactant A will be disappearing as a result of the reaction. The mole balance around the component A is given by the molar flow rate of A into the reactor, molar flow rate of A out of the reactor, and see that these can be expressed as the product of the concentration and the volumetric flow rate. And we also have the reaction term that specifies the rate of disappearance of A as a result of a chemical reaction. And note that every term must have a unit mole per unit time. The rate of reaction is given as a change of moles per unit time per unit volume. Since our reactor operates under constant volume conditions, we simply multiply the reaction rate by the entire volume of the reacting fluid, which we can say is the reactor volume itself. So this gives us moles per unit time, so the units are okay. The accumulation term specifies the overall change of the amount of A per unit time. For the steady state operation, the accumulation term will be 0. Remember, we said that the conditions do not change. The input of A into the reactor equals the output of A as a result of outflow and loss through the reaction. So the net change in the amount of A in reactor is 0.